So to create our own interface, what we basically do is we say public interface, and then we give it the name. Instead of public class, we say public interface. When you're adding a file, you will see that there is an option for Java interface that you can choose also. And we've here are two examples of interfaces that I thought of. So imagine that you have an interface called DMV. So anything that you would have to go and register with the DMV, if you're an object and you want to be able to register yourself with the DMV, then you need to implement the interface DMV. And so the DMV says you need to implement those two methods. So the two methods that the DMV wants you to be able to implement are get registration expiration date and get registration fee, for example. And let's say there's another interface out there called vehicle, and if you're a vehicle, you need to be able to tell me your maximum speed and your year. Okay, so these are two interfaces that we could implement. Now, the nice thing about interfaces is that a class can implement multiple interfaces. So the car can implement the DMV interface, it can implement the vehicle interface, it can implement like any other interface that's out there. Remember, with inheritance, we could only extend one class. So interfaces came to kind of solve this problem in Java, where inheritance only allows you to extend a single parent. Of course, that parent could extend another parent, but you can only say extends and have one class after. But with interfaces, what you can do is actually implement multiple interfaces. And all you have to do is, if you're implementing multiple interfaces, you need to just make sure you implement the methods that they are asking you to implement. So if you're a car and you want to be able to register yourself with the DMV, then you just need to make sure you implement the registration expiration date and registration fee methods and return the appropriate data for yourself. If you want to be considered a vehicle, then you need to be able to return to write the methods that they want you, get max speed and get year. So these methods that you're writing here, notice they have no body. So it's kind of like just the signature of the method, kind of what is it that the method should look like. And it has no curly braces, no code inside of it. You can have fields that are stored in the interfaces. Consider those fields as static variables that are shared by everyone. So anyone that is implementing this interface has access to it. Okay, so here, if this vehicle, this car, wanted to just return the recommended max speed, it has access to it. So when you're implementing an interface, you have access to the information that is stored. So consider them, like I said, static variables that are shared by everyone. Okay. So when you're implementing this interface, you can consider those variables that are stored there as final and static. No one can change them, and they are shared by everyone. So remember, we did talk about, like I just mentioned, that a class can only be derived from only one superclass. However, you can implement multiple interfaces. And when you do implement multiple interfaces, you need to provide the methods by all of them. Just like the car had to implement the methods in DMV, and it had to implement the methods in the vehicle. And so what you do is you separate all the interfaces that you're implementing with a comma. If you wanted car to also implement comparable, it could. There's no restriction on how many interfaces you can implement. If we're looking at a UML diagram, you will see those dotted lines. So dotted lines mean interfaces. So here, a car, because it's implementing vehicle and it's implementing DMV, you will see those dotted lines or dashed lines, and that just indicates an interface. So if you see this in a UML diagram, it just means it's an interface. Okay. Now, just like we had polymorphism with classes, we can also have polymorphism with interfaces. So before we can continue, we really need some interfaces to show you. So let me go and let's implement an interface. So I'm going to come here and let's add an interface called MCC. Okay. And let's say MCC public, let's see, address. Let's say MCC requires you that you provide an address, okay? And what I'm going to do is I'm going to go to the student class and I'm going to say implements comparable, and it also implements MCC. So here we are going to implement public string get address, and I'm just going to say 123 Manchester Road for now. Oh, return. And what I want to also do is I'm going to go to the person, or actually I'm going to implement another class in here. So let's just implement another class called faculty. And they implement MCC, and they're going to also provide that method, public get address, and they're going to return Manchester, Connecticut. I know this is not really meaningful data, but I just want to show you how we can use polymorphism. So we have two classes, student, which implements the interface MCC, and we have faculty, student and faculty, both implementing MCC. Now what we can do in our main, and let's just comment out everything here. That we wrote before. So I have a bunch of students that have been created. Let me just create faculty F1 equal to new faculty. And there is no purpose in creating another faculty because they're going to all look the same. What I want to show you is polymorphism with interfaces. So polymorphism with classes, what we used to do was we said, well, I can create an array list of person objects. And I was able to put in this array list anything that's a person, like a person or a student or a worker. So anything that was person or a child of person, I was able to put in this. Now, with polymorphism and interfaces, I can say I'm going to create an array list of MCC objects. And so anything that implements the interface MCC, I can put inside of it. So let's go here and import java.util.arraylist. And so I can come here to MCC and say add S1. Okay. Since S1 does satisfy the MCC interface, it implements the MCC interface, I can add it. I can also say I want you to add me F1. Okay. And I want you to add me also S2. And any object that implements MCC interface, I can add it. And then later I can go and say for every MCC object in MCC, I can also even use the if instance of instance of, let's say, faculty, and system.out.println m.get address. Okay. So here, because we only have one faculty, I should only get one of them printed. So let's try and test that out. So I got one address printed. Instead, if I say if it's an instance of student, then I should get two printed out because I have two students in there. Okay. And so this is polymorphism with interfaces. It's just like you're treating that as if it's the parent. It's kind of like the parent of all the children that are implementing it, but they're not really children like we did with a parent class and a subclass, but it's kind of similar. So we can use polymorphism with interfaces. Okay. The nice thing also in Java 8 that was introduced is something called default methods. So let's say all of a sudden DMV thought, oh my goodness, we need to implement a new method called print instructions. Now, if they added this method normally, just like they have these two methods up here, if they add it the same way as this, all the code, any code that was implementing DMV will break, because all the classes that were implementing DMV will now need to be modified. So if I was to go to MCC and say, oh, you all also need to provide me a method, get GPA. Okay, I just decided to do that. All of a sudden, now my student class stopped compiling because it says you're not providing the get GPA method, and faculty also stopped compiling. So that's not nice. So what you can do in Java 8, what is provide a default implementation so that if someone doesn't implement that method, they can just use your default implementation. If they want to implement it, they can. So what you do is you write public and the method regularly, but it has this keyword default, and you provide an actual implementation. So I'm going to come here and say public default GPA, and if you don't provide me one, I'm just going to say return 0. So if anyone has a GPA of 0, it means they didn't implement that GPA method. And so a faculty might be okay with that, but a student is going to say, oh no, I need to actually implement this method. So we can come here and say public double get GPA. And since we're not storing their GPA, we're just going to give all students a 4.0 GPA. And what doesn't it like? Return expect. Oh, I forgot the parentheses. Okay, so now let's go to our chapter 10. And instead of printing their address, let's say we're going to print their GPA. I'm going to get GPA. So if it's a student, I'm going to get their GPAs as 4. So here, when we run it, we got 2 students that have a GPA of 4. But instead, if I wanted it to be a faculty, I will get that their GPA is 0. Let's try that out. So the faculty has a GPA of 0. So this was nice that they added this feature in so that when a new method needs to be introduced in an interface, you don't force everyone to implement it immediately. They can take their time to implement it, and if you have a default implementation, they might never have to implement it. So for this classwork, what you're going to do is you're going to practice the comparable and comparator interfaces with the Lambda expressions. You're going to create a rectangle class that stores the length and width as floats, and then you're going to add some methods. You're going to implement the comparable interface, and then you're going to do some sorting. And each time I ask you to sort, I'm going to tell you what to use. So one time I'm going to tell you using the comparator.comparing method. One time I'm saying lambda expression. So make sure you follow these instructions. If you do it wrong, you might still get the right output on HackerRank, but I will actually be looking at your Java code and making sure that you actually used what I asked you to use in each of these steps. And this is how you'll get the top grade for the classwork assignment.